Now creating the tree or checking whether the tree is empty or not is basically the same thing as for the linked list or any data structure that uses pointers, okay? That uses pointers to link a bunch of nodes. So we're going to do it the same way. So we have a tree pointer function called createTree, which basically creates a tree and returns its address. So that's the tree pointer malloc size of tree. And then we're going to fill the properties of that tree. So the root starts at null, and then the size starts at 0. And finally, we return that tree. Cool. Now there's also another function which will test whether the tree is empty or not, which is a Boolean function, and it's going to be titled empty tree. And it takes a tree pointer and checks whether the tree is empty or not. So it basically will return t size equals 0. So if it equals 0, then that'll return true. Otherwise, that'll return false. Cool. Now the next thing that we need to cover, the basic thing that we need to cover in this data structure is basically how to add elements to this binary search tree. So I covered the idea here. The only thing that's remaining is the code. So we said that whenever we want to add an element, we compare that with the root. So we're going to call this root. So we compare our element with the root. If the element, the value is bigger than the value of the root, then we try to add the element to the right child of that root. Otherwise, if the value is less than the value of the root, then we try to add our value to the left child of the root. Otherwise, we just return. We do not add our value because it means that our value is already there. Okay, it's not less, it's not bigger, then it's equal. So our value is there, so we don't have to add it anymore. So let's write a code that'll do that. So basically we're going to create a function which will insert. It'll insert to our tree. Let's say our tree is called t. It'll insert our value, okay? So the first thing that we're going to do is we're going to create a tree node. So we're going to allocate a tree node, and then we're going to fill its content. So the tree node left child, as well as the tree node right child. So both of them will get null. Okay? We will assign to the left child and to the right child the value of null. And then the tree node value will be the value that we wanted to add to the tree. Now, if the tree is empty, okay, if t is empty, if the tree is empty, then in that scenario, then we're just going to add, we're going to copy that to the root. So t root will equals that tree node, and of course we're going to increment the size, so t size gets incremented, and that's it. We're just going to return. Okay? So we just make the root point to our newly created node, and we return that. Cool. Now, if the tree doesn't have only one node, it means that we have to traverse the tree to find the correct location where to put our node. So basically, we're just going to copy the root of the tree, so we do not change it. Okay, so we're going to make a copy. So root takes t root, because we're going to make changes to this root. Okay, we're going to change it while we're looping. So we don't have, we don't want to lose our original root, the root of the entire tree. Okay. So now that we have a copy of the root, we're going to start changing it. So that will be inside a loop. Okay. So I'm going to clear the screen and continue the next page. So here we have while, and we're going to iterate forever. So while true, we can say. We're going to iterate until we hit a break instruction. Okay. We're not going to iterate forever, actually. We're just going to keep iterating until one instruction inside the code will quit the while loop. It'll stop the while loop. So every time, for every iteration, we're going to check whether our value is less than the root value, the value of the node that root is pointing at. Okay? So if our value is less than the value that the root is pointing at, then we're going to basically check if there's an empty spot there to put our node. Okay? So if root left child, if the left child of the root is null, it means that there is an empty spot, right? It doesn't have, this root doesn't have a left child. So we're going to make this new tn node, this new tree node that we created earlier, it'll be its new child, its new left child. So if that's true, then basically the root left child will become this tn, this tree node that we created earlier. And of course, we're going to break. We did what we wanted to do. We wanted to add this tree node to its correct spot. We did that, so we break. This will quit the while loop. Okay? Otherwise, if if the left child is not empty, it's not an empty spot, then we're just going to look through the left child, the left subtree. Okay? So we wanted to search here, and we know that our element will be added to the left, so we update root not to point to itself anymore, but it'll point to the left subchild. Okay, and we will keep iterating. We will keep doing that until we find an empty spot. So else root takes root left child. That's and if. That's and if. Now this is the first case, if the value is less than root value. Now what if the value is bigger than root value? So we're going to cover that now. Else if a value is bigger than root value. If that's the case, then again, we're going to check whether there is an empty spot to the right. So if root right child is null, it means that there is an empty spot there. So let's create a new page there. So root right child will get that tree node, and we're going to break. And else, of course, we're going to update the root. So root gets root right child. Cool. So that's and if, and that's and the other if. Now, what if the value is not bigger than the root value, it's not less than the root value? That means that it is equals to the root value. In that scenario, we're just going to break. So else break. We don't want to add anything. We don't want to change anything. Okay, and that's and while. And basically that's our algorithm. That's the algorithm which will allow us to add our element to its correct spot. So let's code that and then see if it works. Now we said that the function would be some function of type void called insert tree, and we're going to give it the tree pointer and then the value that we want to add. And then we're going to create a tree node, of course, pointer called tn, and cast that to tree node pointer. And we're going to allocate a new tree node, and then we're going to initialize its values. So the tree node left child as well as the tree node right child, both of them gets initialized with null, and then the value gets the value that we want to add. Okay. Now, if the tree is empty, that means that all we have to do is to connect the root to our newly created node and return. So let's do that. So if empty tree of t, then t root gets tn, the newly created node, and then we increment the size of our tree, and then we return. Otherwise, if the tree happens to be not empty, then in that scenario we're going to have to create a new tree node pointer that initially points to the root of the tree. So it'll be called root, and it'll point to the root of the tree. Then we're going to while forever, so while true, and we're going to see if the value is less than the root value, then in that case we're going to see if the root left child equals null. If there's a spot for our node to put, then let's put it there. So root left child takes the n, and then the size of the tree gets incremented, and then we return. Otherwise, we just change the address of the root to move it to its left child address. So root takes its own left child. Cool. Now, if the value is bigger than the root value, so our value is bigger than the root value, in that scenario, we're gonna do basically the same thing. So if root right child, so if the right child is null, then we're gonna put our element there. So root right child takes the n, and the size gets incremented, and we return. Otherwise, we just change the root. We update the root with its own right child. So root takes root right child. Cool. Now, if the element is not bigger, not less, then it's equal. So in that scenario, we're just going to break. Okay, and basically that's the code that will add basically the numbers to our tree. So let's compile this to see whether there's an error of syntax. Well, there's no error. Let's create a new tree, and let's call that t equals create tree, and let's insert a couple of elements to the tree. So insert tree to the tree t. Let's insert number 5, then insert a couple of other random numbers. So t7, t3, t4, and so on. So one final number. Let's insert 7 again. Cool, and let's compile. That's great. That's great, except that we cannot verify whether it worked or not, okay? There's no syntax error, there's no runtime error, but we have to create a function which will print the tree so that we make sure that the elements got added to the tree correctly. Cool.